Okay, so let's take a quick look at what we were doing here for testing. So I decided on this Hyundai, this 2014 Hyundai Santa Fe with the 3.3. It was a limited model, all-wheel drive. This came in with a P0263. Let me pull up Protoman quick. I've already got it up here, but in case you're wondering, DTC index, engine control system DTCs. Now this is the only code that it had in it. Now the symptoms on it were that it was stumbling only on a cold start. It would stumble, and then it'd come out of it as the engine temp came up. The vehicle would run fine. Okay. It was not throwing misfire codes or anything like that. Check engine light wasn't flashing. Just was on with the 263 in it, P0263. So let's just scroll down and find a P0263 and just read up on it, because I'm basically going to walk you through what I do when I get a vehicle in for a code or a symptom. Obviously I have a code to go on here, and it's a cylinder 1 contribution balance code, okay? So if we just read here, general description, PCM monitors air-fuel ratio of each cylinder based on the O2 sensor signal. So the PCM performs this monitoring for 20 seconds with a particular condition and corrects fuel quantity of each cylinder. Now it does that by adjusting, adjusting how much on time of each injector. Okay, so it can adjust how much fuel it's delivering to each cylinder based on that O2 sensor signal, and the response, the upstream O2 sensors are going to drive the train on adjusting the fuel injection on time. Okay, how long it's going to spray. PCM sets DTC if it detects an imbalance of air-fuel correction in each cylinder. Okay, again, I'm not an expert on Hyundai. I'm just a fellow technician, just sharing what I learned from this case study, and I'm not a certified instructor by any means. I'm just sharing what I've learned here, guys. So please understand that. I understand that there's people out there, other technicians, even guys that aren't technicians, that are really knowledgeable on stuff, and I would appreciate it if you guys would leave comments down below and correct me if I misstate something or I'm not interpreting this correctly. Okay, I actually encourage that. Just be respectful and do so, so other people can learn. And the reason I'm sharing a lot of this information, like I said before, is because I want to help other technicians grow and learn, and this is one way of doing that. Okay, that's how I learn. So I'm learning right now, actually. So, anyways, if we look at DTC detection, detecting condition, you can see erratic air fuel correction value, detecting condition, enable conditions, engine coolant temp has to be higher than 40 degrees Celsius or 104 degrees. The engine speed has to be lower than 3,500 RPMs, and no disabling faults. So, like, it can't have like a control circuit fault on that injector, or a circuit fault on probably like an ignition coil, I'd imagine. Otherwise, it's not going to set this code. Threshold value, individual cylinder fuel control multipliers lower than 0.84 or higher than 1.14. That would be something you'd look at, probably like a factory scan tool, and see. Diagnosis time is within 3 seconds of it happening, and then the mill will come on after 2 drive cycles. Okay. Possible cause: fuel leakage or stuck in injector, air leakage in cylinder, so like a vacuum leak, ignition system error in cylinder, so like an ignition problem, coil problem, spark plug problem, abnormal compression pressure in cylinder. Okay, so there's a few variables that you have to consider here. You have to consider your ignition coils, and this is cylinder 1. Okay, now granted, misfire strategy on a Hyundai. I mean, I don't know how accurate it is, but given that it set it for cylinder 1, that's the one I'm going after. I did look at scan data when I did this, looked at some trims, but it really, I didn't spend a lot of time because I was like, immediately when I seen this code, I'm thinking, because of what I'm reading here, I'm immediately, number one, fuel leakage or stuck in injector. I'm thinking injection problem, okay? And given the symptoms. So you got to think of the symptoms. Symptoms are car's first started up, it's cold, okay? It stumbles a bit, and then as it warms up, the stumble goes away, and it's like it's not even happening. Crazy. Absolutely crazy. You look at trims don't indicate a vacuum leak where we would have positive trims with a correction with RPM increase. It's a Hyundai. I'm using a snap-on scan tool. It's very slow. I'm in generic mode to look at my trims, and I'm not seeing anything that stands out to me to indicate a vacuum leak. This did have clear flood mode, so, you put your accelerator pedal all the way to the floor, give her a crank, and it'll cut injection pulse, and then you can listen to the sound of the engine, and if you have a hole or a compression problem, usually you can hear it. First thing I did, of course, and I didn't hear anything, and cranking it over cold and clear flood mode. So I'm not really too concerned about compression. Doesn't mean it couldn't have like a valve seating issue. Doesn't mean it couldn't have, some kind of compression issue. But based on that alone, I was like, okay. And the symptoms, I'm like, if it had a compression problem, why does it change with engine temp? That's my thinking. Okay. So I'm immediately thinking injection. Here is what they want you to do to diagnose the vehicle. Of course, they're going to run you through all this. It could be poor contact at the connector at the PCM, yada, yada, yada. But we didn't have any circuit faults, so I'm not really... I'm not saying it's not possible. It is possible, but it wasn't really my first... what I'm thinking is like a spray problem, because like on these direct injection engines and these injectors, like if they get a little bit of carbon buildup on one of them ports, one of the little spray holes on the tip of the injector, it's not going to spray right, and it can cause problems. So anyways, they want you to do a power balance test. I did not do a power balance test. I could have, but what's the point? In my opinion, because like if I drop, I cut an injector and I'm looking for RPM drop, I'm still going to come to the same conclusion. Like it still doesn't rule out ignition versus injection. Okay. I guess I could have done this to maybe confirm, yep, okay, cylinder, whatever. But because of the intermittent, like this car was so intermittent, like it would do it sometimes, it would stumble, and then other times you'd start it up cold, cold. When I say cold, I'm saying like, under 150 degrees on the coolant temp, okay? Sometimes it would stumble, sometimes it wouldn't. It was really weird. So, moving on. Here they want you to, where is it? Check for air leakage. Okay, so they want you to check for vacuum leaks, vacuum hoses, splits, leaks, and connections throughout by gasket. Obviously, I do an underhood inspection, smell for rodents and all that. And I wasn't seeing anything, but the injectors live under the intake manifold, so it's like really hard to see, if there is in fact wire damage. So immediately in my head after looking at this, and literally all they want you to do is they want you to check fuel pressure. Well, why am I checking fuel pressure? It's only affecting one cylinder, so what's the point? Like if we had a fuel pressure problem, you would sure as hell would think I would see that as far as like a lean code or a rich code, whatever. So I'm not really concerned with fuel pressure. I'm not concerned about the fuel pump. Not concerned about like the high pump, because this has a direct, it's direct injection, so it's got a high pressure pump. So I'm not really concerned about that because we're only dealing with one cylinder. Check spark plug. Okay, well, yeah. Obviously I'm concerned about the ignition coil, and I'm also concerned about the spark plug. That's another concern, because if we had that, like let's say we had like a secondary leak, but again, we're not throwing misfire codes. You sure would think we'd throw a misfire code. We weren't throwing any type of control circuit faults for the ignition coils. So, is it an ignition problem? And then again, with symptoms, it doesn't match. It really doesn't match like an ignition problem, because like it only stumbles when cold on startup. So I'm more concerned with like a vacuum leak or probably like a fuel delivery issue concerning the injector. I did smoke the intake on it because I wanted to inspect the air filter and whatnot. So I did smoke the intake, and I didn't see anything. So I wasn't too concerned about a vacuum leak. Here they want you to measure like coil resistance and all that, and I wasn't doing that. Okay, because cylinder 1, that's all they give you here too. They don't tell you. They literally tell you to check the ignition system, and that's it. Okay, and then like verify the repair. It doesn't make any sense to me. I'm sorry, but like basically it's leading right to injector once you rule out vacuum leak or ignition problem. But in order to test these ignition coils, cylinder 1, let's look at a cylinder layout real quick. Where we go, common specs on this 3.3. So if we come down to ignition, firing order and cylinder identification. So firing orders 1, 2, 3, 4, 5, 6, pretty straightforward. Then let's look at our identification on a V6 on a Hyundai. And again, traverse engine. So this would be firewall side 1, 3, and 5. So cylinder 1 was on firewall side. Well, the intake lays over cylinder 1. I'm not messing with that. I wasn't going to. Now, in my head, I was thinking, okay, I'm going straight to PCM, because the PCM is easy to get to on these, because I thought, okay, all the injector controls and all the ignition controls and everything is going to go to the PCM, because it's direct injection. So your high, what do they call it, injector high and your injector low will go to the module, right? And then it controls that injector. Well, this one's set up a little different. Same with your ignition coils. This one's set up different, and this is what got me on this one, because I've never dealt with this issue on a Santa Fe, so or at least on this engine. So let's look at, because I'm doing a preliminary on this fault code. So like I haven't really built time yet. I'm just kind of getting an idea where I want to go. So I went to wiring diagram, and I just wanted to look at the injectors. Engine performance, 3.3. Okay, so let's find these injectors. Not worried about it. I wasn't going after ignition. Again, didn't match the symptoms. If I had a coil problem, I did drive the vehicle, and like, if I had a coil problem, you sure as heck would think I would feel it, under load, and I wasn't. Same with an injector, honestly, but this one didn't. It was weird. Okay, so here's our injectors. Okay, 2, 4, and 6, 1, 3, and 5. If we follow it all, okay, you're going to have your high and your low side, right, for the controls. But if you follow them all down, they all come to this IDB. Well, what the hell is an IDB? Injector driver box. Nevertheless, I didn't know what an IDB was, and then I kind of scrolled up, and I'm like, okay, well, here's the PCM. They're telling me this is the PCM. Did they just mislabel this and call this a PCM? Like, I don't know. Like, E100 IDB, okay? That's the connector for all these, here you can see injector 3 low, injector 6 low, injector 6 high. You got your injector 2 input, injector 5 input. Now I will tell you that these input ones are the controls. So like, let's follow this up real quick. So like injector 1, input. Where's injector 1 input? Right. Why am I missing it? Injector 1 input right here, this black wire. So follow this black wire up, goes 23 next diagram. Follow it over here, it comes up, and it goes to our PCM. Okay, so the PCM is controlling the injectors through another module. Okay, and I didn't put 2 and 2 together right away, so I went right to the PCM, unwrapped the harness, getting ahead of myself. I'm like, oh yeah, I'll just unwrap this. It's probably the second connector, so I took them off, started unwrapping them, wasting time, and I'm like, you know what, if I have to test the coils, at least I'm there, right? Because I know the coils go to the PCM, but the injectors don't on this one. And that's different than GM or a lot of vehicles, because most of them go right to the PCM. Not on this one. This one has a separate module, and I'll show you. So what I was worried about was getting a pinout, okay? Oops. I wanted a pinout. So E100 IDB. So what I did, because obviously Mitchell's a little different, is I went into my manual, and then I went into keyword search, and I typed in E100 IDB, okay? And I did a search, and boom, OEM connector end views front harness, injector driver box. Okay, that's what it's called, injector driver box. Okay, so the injector module, okay? Connector end view, E100 IDB. So I clicked on this, and boom, I got my pinout, okay? Now, where the hell does this thing live? Because, of course, they don't tell you on the wiring diagram. So now I'm like, okay, I got the pinout. That's cool. And they do their colors a little different with Hyundai. Like, they just use one letter. So B could be brown, black, I don't, whatever. But nevertheless, doesn't really matter. Printed this off. And then I got to find this injector driver box. So where did I go for that? I guess we could just do a search, right? Injector driver box. Okay. So here, diagnosis, they're telling us what it does. So let's click on that. That's, of course, where I went because I wanted to know more information. This thing would load. Okay, general description. Injectors jet out high-pressure fuel calculated by the PCM to each cylinder. Direct and separate injectors improve fuel efficiency and engine power. The injector driver box controls injector operation. If the IDB receives signal for injector operation from the PCM, IDB boosts the voltage and uses current by voltage difference between high and low side of injector current, or circuit rather, as injector operating current. So that's interesting because, okay, so like the PCM is controlling the injection through a separate module. Kind of like, I don't know, a lot of the diesels kind of run this way, I know. So are they doing this separate module to like protect, like so that the injectors, because they're using high voltage, I mean, they're using like 50 volts, 40 volts, they're using higher voltage and higher current. So are they protecting the PCM in case you have an injection problem? I have no idea. Okay. That's what they give us. Okay. So I thought that was kind of interesting. Let's go back. See what else is in there. It looks like it just repeats. Here's one that's on 3 of 3. What's this say? The injector driver box monitors battery voltage supplied to the IDB from the main relay while the engine is running. Okay, great. Oh, okay, so this is all under DTCs. Like different DTCs that would set. So this is just kind of what I did. And if I remember right, I couldn't find it in here. So I went back to table of contents. And the reason I'm showing you this is in case you're new to it, trying to figure out where stuff lives. Did I go under engine performance, fuel delivery, general information? Let's check that out. We go under troubleshooting. Nope, nothing in there that I find of interest. Fuel delivery system. So if you look in fuel delivery system, they're not even listing it in here. But they do give components and component locations. So let's click on it, but it's not in there. Okay. So let's try accessories and equipment. Let's try communication devices. Cluster, driver door, power gate, smart junction. I gotta remember where I went. Where the hell did I go to find this thing? I know I found it. Oh, goodness gracious. Engine mechanical, fuel system, general information. I'm trying to remember where the heck I found it. Struggle is real in the aftermarket. I gotta remember where the heck I found it. Let's go back in here. And see, they don't even list injectors in here. That's the other thing. Repair procedures. You know, they don't even list fuel injectors in there. So let's try mechanical again. I think it's the same information if I remember right. Yeah, I gotta remember where I went for this. Let me look around a little bit. Yeah, see, this is the problem when you're dealing with aftermarket systems, is trying to find where the stuff is located. Okay, again, I did another search of the connector. Sorry guys, I should have probably thought of this before I started the video, but no big deal. Now you can see the struggle is real. Sometimes it takes a little time, and this is the time that you lose, and that's why I hate flat rate. Okay, so E100 -IDB, engine control system. I believe this is where I found it. Oh, we're getting on the right path. Removal. Yep, that's where it was. Why they put it there, I don't know. It's under injector driver box, under engine control system. Okay. So you go in here, and again, they're giving you all the pins and what they do. I was looking through here, and they give you a lot of examples of like injector driver waveforms and all that, which I thought was interesting. But here it's telling you the removal procedures. You have to turn, obviously disconnect your battery, then remove the glove box housing. Now I will tell you this. This is not as easy as it looks, okay? First of all, when you get in there, it's not going to be, this right here does not do it justice, because there's this big connector on the side of the HVAC box that's in your way. There's another module, the audio module's in your way, so that's got to come out. They don't tell you any of that. Okay? They're just telling you literally go in there, or once you take the glove box housing out, which is kind of a pain in the rear end, but it doesn't look like it. I mean, you look here, you can see that you got to remove all the trim paneling, okay? And you're thinking, oh, okay, I'll just take that glove box out. Yeah, not so much. Because if you read, they want you to take out, first of all, you got to take out the glove box. Yep. And then you got to remove the shifter, assembly, the shifter, top end. And then you got to pop up the trim paneling, disconnect its connectors, pull off these trim panels, which I only pulled this one off right here, which that was a bear. Because, plastic works well. And then you got to take that off the side, on the passenger side there's, and then take out your screws, and then you can remove that. And you take off the bottom, basically the knee bolster, whatever you want to call it. I don't know, the cover underneath the, what are they calling it? The crash pad. Yep, and then that wasn't even there. And then, yep, you take all that out. All that's got to come out just to get in there. And then once you get in there, they're not even telling you what else you have to take out, okay? So I'm like, okay, now I'm like almost at, I'm getting to the point where it's like, okay, my time's ticking. Estimate guide. So I'm like, all right, how much time is it going to take me to test this damn thing? Well, guess what? You can look through here all you want. Like you go to interior. Where is it? Exterior, interior trim. Okay. You're thinking, oh yeah, glove box, glove compartment lock cylinder. Well, 0.6 hours. Yeah. Bill an hour. Bill at least an hour. Okay. Then you got to factor in too, you got to test it. So there's another half hour. Plus your half hour, you already got looking up and researching it. So you're at 2 hours. Then another half hour for the ignition system if you have to go there. So 2.5 hours. I'm sorry. But straight up, you'd be honestly, this is what I was thinking at this point. I'm like, okay, I'm at 2.5 hours just to do this. Well, okay, how much is it to just straight up remove the intake and go right to the injector? And I should have done that. Not going to lie. Honestly, but I wouldn't have learned what I learned. I guess I could have scoped them there, but you can't because you can't run it once you have the intake apart. Let's see, where do we need to go? Mechanical. So what's intake removal? Or actually, let's go to fuel system. Let's see what it pays to do an injector. So to do a fuel injector, which of course isn't under fuel system, because why would it be? That would only make sense. Oh yeah, under performance, fuel delivery system. So where is injection? So what are they giving you for a diagnosis time? 1.5 hours. So keep that in mind. 1.5 hours to diagnose the fuel injection system. Okay, so that's decent. And then what about the ignition system? What are they giving you? Engine compression testing, 2.1 hours. Add 0.2 for wet compression retest. So 2.1 hours to do a compression test. Well, technically I didn't do one. I didn't think I needed to. 1.5 to do the ignition system. Oh, let's look at our ignition system. What are they paying for testing of cylinder leak testing? Yeah, they don't even give it to you. So 2.1 plus 1.5, that's 3.6 hours just to test. Okay, properly. I think we built 2.5. It took me about 3, so I lost time on this job. So that's why I'm making the video, is just to kind of give you guys an idea of how to, like, I guess you could go analyze engine performance. So 0.7 plus 1.5, what do you get? About 2.5. So that's fair, right? So that's kind of how I do it. Nevertheless, I hope you guys gain something from that. So let me get into where we were at. Where were we? Electrical. We need to go to wiring diagrams real quick. Let me get back out of here. Search. Well, it doesn't matter. Now you know where to find it. You know where to find the pinouts. That's what I'm looking at. That's what you're looking at here. So this module here that you see on the floor here, you see my wire mess, or my scope lead mess, and my amp clamp still wrapped around one of the injector control, one of the injector wires. Okay, I just took the amp clamp, went right around injector number 4. I think I chose number 4 and number 1. Number 1's my problem child. Number 4 is my known good. Okay, because I wasn't flagging a code. This module right here is the injector driver module, okay, or driver box as they call it, and that was, back up in here. This audio unit has to come out in order to get this out, okay, and yeah, I just, I was already there, so I might as well just take it all the way out and make it easy on myself. Now, what I was getting on this Let me pull that wiring diagram up real quick just to show you on the wiring diagram what I was getting on this when I go to the scope here. Again, I apologize for the length, but how is he supposed to learn it? So once I got to the injector module, or driver box, if you will, is I looked at these pin, I had that pinout that I showed you, and then I was like, okay, well, I want to capture as much as possible, so I'm going to use all 4 channels if I can. So I'll do injector 1 first, and I'll get injector high, 1 high, and then injector 2 low, or injector 1 low, right here, this red. And then I also want to get my injector control from the PCM. So there's 3 traces, and then I want to get its amperage. So the amperage doesn't matter. I can go around the low wire, and they're a twisted pair. So anytime you see GDIs, they're always going to come into the PCM or the injection box, and they're going to be a twisted pair. Okay, so it's really easy to identify them because they're always twisted, just like your comm lines, right? Your network lines. So your injector 1 low. Or injector 1 high, doesn't really matter. One's the high voltage side, one's the low voltage side, and they're both monitored by this module. I mean, usually they are, in case something shorts or whatever, and then it can flag the DTC, okay? Then I wanted that input from the PCM, and I wanted to get its current with my amp clamp. So that's what these 4 traces are going to be that you're going to see on the scan or the lab scope. And I thought it was pretty cool because I obviously caught the problem. So, and I am amazed that this thing was pulling as low of an amperage as it was. I mean, this thing was literally pulling like an amp. Injector 1 was pulling an amp. Injector 4 was pulling a little over 10 amps, okay? A little over 10 amps. Pretty interesting. So, let's get into the scope captures, and we'll go from there.
All right, so I had to go outside because otherwise I'll get interrupted by my daughter or something, and it'll be distracting. So like here we're gonna go into these waveforms that I saved, okay? So if you're using the Zeus, I'm trying to walk you guys through everything from, an aspect of, if you're not familiar with the platform, at least then you get an idea of how I manage my data and do my thing, okay? So data manager. And these are the ones I saved today. And you can see here I labeled it 14 Hyundai Santa Fe 3.3 liter injector 1 before, okay? Because I'll probably get after captures, but I really don't need to because I got injector 4 before, which, to be honest with you, injector 4 was a known good, okay? So let's open up the known bad first, okay? Injector 1. All right. And I saved it already zoomed in, but if you were using the scope, similar setup, right? It's going to look like this, okay? So in order for you to, let's take these cursors off. Let's hide them, okay? And then let's take our dotted line here, and then you can see up here the red. So this red trace is the control for injector 1 coming from that PCM, okay? And the yellow trace, well, let's zoom in on one. So let's go in on, let's see, let's zoom in on this one right here. We'll go on this one. So hit our zoom function. Let's come right into 2. And we'll come over here and we'll zoom to 1. Okay. So let's take a look at this. All right. I've got them all overlaid right here. Okay. So that's why they're all like lined up with one another. And the reason I do that is because then you can kind of see where the voltages are, and they're all the 0 line is relatively even for all the traces, and you can see our red trace is at 12 volts. Okay. Now if you want to see what I was on for scales, because I know some guys new to scopes might be wondering, these are my scales, and this is my time base. 5 millisecond screen. I'm filtered on all of them, and obviously I'm in the 12 volt DC probe setting, okay? And then I got a 2 volt scale on my amp clamp. My amp clamp is the blue trace, okay? So I'm getting amperage with the blue. Our injector low is the yellow trace, our injector high is the green trace, and then the control is on a 20 volt scale. That's the control that they were talking about from the PCM, okay? So if you look here, this is injector 1. Now take a peek at this and just look at it, okay? Just look at it. All right, now let's open up injector 4. And you're gonna see the difference in the blue trace. See it? Yep. We're done. But I just kind of wanted to look at this because I always think it's interesting to see how these direct injection engines and these injector circuits look. And that's why I grabbed all the traces for each one. And that's how I learn. Yeah, that's how I learn, guys. I don't know how, you know, the only way to learn is to look at a known good, look at known goods. And then you look at, when you see a bad compared to the known good, you're going to see the difference. But if you look here, you're going to see that blue trace. This is the amperage, okay? You can see the turn on. And the control from the computer is fixed at 12. Now, the one thing I do regret is I did not find out where that 12 volts is coming from. I'd imagine the 12 volts is coming from the injector module, and then the PCM grounds it to turn it on. But in either case, it doesn't really matter. The PCM grounds it. That's what I would assume. That 12 volts is coming from our injection module. It pulls it down to ground to start the turn on. Okay, and the transistor in there. Okay, and then that module, that injector module, starts the current flow. Okay, through the high voltage. You can see the high side goes up. What are we getting there? On our green trace, almost 50 volts, just under. Okay, that's why I put my grids on. About 50 volts. Okay, now as that amperage builds up, the current flow goes up. It's gonna peak out here, and there's a current limiter inside of the injector that's gonna, like, it's kind of like a peak and hold injector. All right, now Paul Danner, Scanner Danner, he talks about the old peak and hold. I mean, a lot of guys do, right? I'll put links in the description below. I've got another video on this for I think a Traverse, a GM36 that had, rodent damage to the wiring, and I had pulled some interesting traces. But that one was, the GMs are different because they go right to the PCM. These do not. These have a separate module, so keep that in mind. But in either case, the green trace is our high side, and you can see the voltage goes high, right? It comes from 0 volts. Once the computer turns it on, it goes high. It goes up to 50 volts as our current is increasing, okay? And we're pulling how many amps there? Again, I'm using a low amp clamp wrapped around that one of the, high or low side voltage wire, the twisted pairs going to that injection module. And if we look here, we're on a 2 volt scale on our blue trace. Okay, the 20 amp, the low amp clamp in the 20 amp mode is going to be 100 millivolts per amp. So if you look here, how many volts are we getting here? Just under that line. Yeah, that's like 11 amps. That's almost 12 amps. Just under 11, what do we got there? About 10 and a half, 11 amps. About 11 amps. It peaks out, okay, as it's holding it. And then once that current limiter, will start to drop the amperage, you can see we get this voltage spike on our low side where the injector, I would imagine, is actually like already opening. It's opening as the current's rising and the voltage is rising on the high injector high, and then as that current limiter, again, I'm not an expert, but as that current limiter gets to its limit, it kind of brings it down, and then you get this voltage spike, and that's going up to, on our yellow trace, almost 40 volts, okay, about 41 volts or so. Well, no, probably just under, about 39 volts. I could put cursors on, but I'm not gonna. And then as it comes down, it's holding it. See that? See how the amperage kind of levels off at about, oh, what is that? 300 millivolts on the blue trace. 300 millivolts where it's bumpy there on the blue trace. So it's holding it at about 3 amps. Okay, and then you see these little spikes on the high side control for that injector. Okay, 1, 2, 3, 4 of them, and the computer's still holding the ground the whole way through, and then the computer lets go of the ground, and then we get this last voltage spike here of, on the yellow trace, 45, 46 volts. Okay, and then the injector's gonna start to come, that voltage starts to come down, and you see a little pintle hump. Like if I zoom out, let's come into this again. Something else that I found interesting is, take a look at that. What's going on there? Interesting. Yeah, you see that? Look at this. Let me bring this out slow so you can see what I'm seeing. Look at this. So the injector is not being commanded on by the PCM, but kind of. I mean, these are the other injectors, I'd imagine. But look at that. Like this, the high side and low side, it's interesting. That's why I wanted to look at it. So let me bring this in so I can finish what I was talking about for the closing event. Okay, so there's 1, 2, 3, 4 on the green. That's what I'm looking at right now, is the green, the high side, okay, of that injector. The low side, right after that, you can see the last spike there, and the injector's now coming into a closing event, and this would be like your pintle hump here. Okay, I would imagine. Again, I'm not an expert. Hopefully somebody watching that knows more about it can explain it in the comment section below. I'm just showing you guys, okay? This is a known good on a Hyundai Santa Fe 3.3 liter amperage, high side driver, low side driver, and the control from the PCM to that module. Pretty wicked cool, right? So let's look at the bad, or injector 1, the one with the trouble code. Okay, and look at the difference. And look at the amperage difference here. So that current limiter inside that injector, from what I did a little research, but I would imagine the current limiter is bad. Okay, because I looked at these voltage values, and the voltage values are all the same. So if you didn't pull current on this injector, if you didn't pull current, you didn't get a current on it, you're not going to see this problem. Okay, you're not going to see it with lab scope, because by all accounts it's going to look the same. However, on the high side, how many little 1, 2, 3, not 4, 3. That's my thought process on it. I thought it was pretty wild. I don't know if you can determine, like you can on a port fuel injected, a port injector, which isn't peak and hold style or whatever's. I don't know if you could really determine based on the amperage whether or not you have a restricted injector, or maybe a spray issue from this. But it's a start, right? I mean, if you look at enough of them, eventually you're going to start to see patterns. I just thought this was really cool. So pretty interesting. What are we spiking at the end there on the closing event? Yeah, it's lower, not by much, but by a couple volts. And then this one, yeah, about 36. Yeah, so a little lower on our voltage too, on the yellow trace, on the what would that be considered? That'd be considered the low side of that injector. So it's pretty cool. Obviously on amperage, if you look at the blue, what are we getting for amps there? I mean, nothing. 100 millivolts on the blue trace, so 1 amp. Crazy. So this is crazy. These captures were taken when the engine coolant temp was under 150 degrees. And as the temp came up, this thing ran great. So I don't know if they were shutting the injector, if it's shutting the injector down. I have no idea. Or is it just enough where it can still like open and close and still spray enough to make the engine run smooth, but crazy. This is what was causing the stumble. I would imagine this thing is spraying, but it's not spraying enough, and then it's leaning out, or whatever. And the O2 sensor, because again, the O2 sensor signal is what's monitoring this. I don't know what I just did there. Is monitoring the signal wire on the O2 during this event. Okay? Pretty crazy. Anyways, I wanted to show you guys that. This is bad. That is good. Okay? Considerable difference. But without the current ramp, you could miss it easily. I did, until I looked at it closer afterwards, and I'm like, oh wow, look at that. And then I'm like, well, what about this? Me and my coworker standing there, or my service driver standing there, and I was showing them, and I'm like, well, let's count these. 1, 2, 3, 4. And then I, compare it to number 1 or whatever. The one with the problem, and lo and behold, different. Interesting. Again, not an expert. Just thought I'd show you guys that. So I hope you guys like that. I don't know. Do you guys like that? I do. I think it's pretty sweet. So anyways, thanks for watching. Catch you on the next one. Hope somebody learned something from that. And if you guys got any suggestions or anything to add or whatever, maybe I misspoke on something, let me know in the comment sections below, or the comment section below. Pretty cool. So take care.